Okay, we're in section 13, rotation of axes. And what we're going to be doing is we're going to be taking conic sections and rotating them now. And we're going to rotate them through an angle theta. So what I want to claim about this section over here is that there are some derivations. Some of those derivations are going to be optional. I will talk about how to do the derivation, but I'm not going to go through the groundwork on it. All right. However, there are optional assignments for those students wishing to go forward in that. And this sort of reminds me when we're talking about the conic sections, there were also some optional assignments on deriving those formulas. All right. So here's the deal. We're going to talk through this. It's a tough section. There's no doubt about it. It does depend on trigonometry, and it does depend on knowledge of conic sections. So we're going to start off with this over here, and I'll just briefly go through what we're doing over here. We're going to start to see conic sections where we have a term that looks like this in it. And we don't like that term. And I'll be honest with you, it makes it more difficult to graph it. And so what I would claim over here is that, again, not a memorization skill. It would be nice if B were 0, though, because if that were the case, I probably could manipulate this thing to understand what conic section it is, all right? Now, granted, you may want to think through that. And, I would say you may want to think through that, but the bottom line, I'm not asking you to memorize that. Something about circles, something about parabolas, something about lifts, something about hyperbola. We'll get to that later, though, all right? Now, what we're going to be doing, though, is we're going to rewrite the equation. This is the equation we're going to rewrite over here. We want to rewrite that guy by using a substitution that will get rid of the B, right? What do you mean by that? That B term will disappear. And the way we do that is we rotate the coordinate system, all right? We will go through this, but I'm not going to go through the derivation. It does require substitutions, it requires expansions, and then it requires solving a trigonometric equation to do that. Because we're going to be revolving this thing, counterclockwise through a theta to get rid of that BXY thing. And we'll have pictures, and we'll get to that when we get to it. All right, we'll talk about what the substitutions are and how to do it. I'll outline the method for you. I'm not asking for memorization, but we'll talk about the method one step at a time. We'll take simple examples to start with. We'll go through the examples at the whiteboard. And again, we'll switch that later. But the bottom line is that method. And it's really going to be a method where we follow steps. Where the steps going to be step 1, step 2, step 3, step 4, step 5, step 6. We'll go through it all. All right. So we'll go through this. We'll go through examples. I'll do some manipulation, but I'm not going to necessarily derive the formulas. Those are optional homework. All right. Now, granted, some of this stuff is nightmarish for expanding, but we still can do it. I mean, we still can do it, and we will be doing it. All right. And you need to learn to do that. Then what happens over here? You start to realize that what we're doing is we're rotating things through an angle theta counterclockwise. So if you look at this thing over here, this is an equation of an ellipse. All right. Now, someone says, what are these axes over here? Well, this is the rotation we just did. What are we doing? This is going to be the X prime, Y prime. Again, we'll go to the notes. We'll talk about later. What's over here? X and Y. What do? We rotated it. Now, certainly someone says, how did you rotate it? Through an angle theta counterclockwise. All right. So here's an example of a graph of an ellipse. It's got a BXY term in it. You notice that right over here. I went through some work to eliminate that, and I realized it was a rotation through 30 degrees. We'll go through those in details. Do not worry about rotational invariance. Worry about the examples. I'm going to go to the whiteboard. All right. As I go to the whiteboard, you probably, I'm not going to say sit back and relax, but sit back and listen. And again, it's going to take some thought. There's no doubt about it. This is not something that people is boom, it's done. It's not. It doesn't work that way. So let me do a new share. I'm going to do a whiteboard. Give it a second to warm up, and I'm there. All right. Where are we? We're on the rotation of axes. So let me take a look. And again, I want to emphasize what we're doing over here and what you need to follow. And this is no mystery over here. We've been doing this for some time now. What have we been doing? We've had topics. And what topic are we doing now? We're doing the rotation of the coordinate axes. So that's what we're doing, rotation. And what are we returning? The XY axes. This should make it easier for us to graph when we rotate things. All right. So I want to point out that it's important that you listen to what we're doing in lecture. You try to follow what we're doing. You need to study it, though. You need to go back over the notes and study what we present to you. You need to look at the examples that we're going to eventually present to you, rework those examples if you have to. But the bottom line is you also have to do the supplemental exercises to make sure you understand what's being presented to you. All right. I do want to warn you about this. In the future, when you go to another college, they're not going to talk to you this way. They'll assume you're doing this stuff. They won't tell you to do that stuff. Just like when your parents are really young, they might tell you, hey, did you wash your hands? People stop talking to you that way. All right. So what I'm going to say over here is you need to catch on to what we're doing over here. And that is you need to pay attention to lecture. You need to pay attention to the examples that we're giving you. And then you need to study that material. And then you need to try it on your own. That's when you're going to determine if you learned the material or not, when you try things on your own. Now, granted, we give problems that are very similar to what we're giving to you in the notes, right? This is a typical structure of an educational environment, all right? Let's go to the next page, and we're going to start talking through this now. And certainly when I talk through this, I want to point out what I'm interested in, right? I'm not interested in memorization. I'm interested in, can I understand what they want me to do with these problems? Well, first of all, they want to emphasize here that I've got troubles. I want to point out what the troubles are going to be. The troubles are going to be, these equations are going to be in this form here. And I'm going to say this is typical conic section form, right? But the problem for me is not that. The problem for me is this. Because this is the thing preventing me from determining if it's a circle, if it's a parabola, if it's an ellipse, or is it an hyperbola, or is it possibly degenerate. That bxy is a killer. We want to get rid of it. And I want to talk through that now. So as I'm going to talk through this over here, my goal is to understand what they're going to do. And I will draw pictures for you. But here's what I said. As you should know by now, none of the prior examples had an xy term in it. None of them did. None of them. So none of the prior examples had a term xy in it. Now we're presented with this bxy. So what were the other guys that we had? The b was always 0. We want to go back there. It's familiar territory, right? It's familiar territory. So really what are we trying to do? We're trying to get rid of this term over here. In other words, we want to find something that makes the b equal 0. All right, we want to get that b to be 0. All right, that's going to be tough, right? So what I'm going to say is over here is that all the other problems, the lines of symmetry, right, except in a circle, by the way, were perpendicular and parallel to the coordinate axis. So what we're going to do now is we start to realize these lines of symmetry now have become rotated. And I'm going to say rotated counterclockwise through some acute angle theta. All right. So what I want to talk about is we're going to transform it to another coordinate system that's been rotated. So xy is now going to be the point xy rotated to an angle theta. Right. So the x prime y prime is going to be the point xy rotated an angle theta, now counterclockwise, and theta is going to be an acute angle. It makes the problem more difficult. There's no doubt about it. For me to do this makes it much more difficult. But my goal, after I do that rotation, I should be looking at a very simple equation in x prime, y prime that I can actually figure out. So what I want to do is I want to pull on the side, and we'll talk about this in one step at a time. This over here. Whoops, I made a mistake. Give me a second here. I do want to point to a little video there, and you're more than welcome to watch that video if you want to. I'm going to talk through it though. Right? As I do that, I'm going to draw a picture of what I'm reading. And this is something that you want to learn to do, certainly when you're reading a textbook, and especially a mathematics textbook or an engineering or computer science, draw pictures. All right. So I'm going to draw a little picture over here. You can get black. And I want to try to see if I can understand what they're saying. All right. So it says, first let the point xy be written as, well, when they do that, my understanding when they do that, I want to circle what we're doing over here. We're going to do a point xy, and I'm just going to, draw what I've always done, something like this over here, and I'll put the point here. All right. And I'm going to tell you this is the point xy. And they say, first let the point xy be written in the form. Well, now they're going back to that old fashioned thing that we've done. And the form over here, this is going to be theta plus beta. All right. This is R. Now, what do I mean by that? The radius of the circle that goes through there. All right. This is a rotation problem. If you were to draw a circle through over here, I'll tell you what it would look like. It would look like this over here. You get the idea. Whoops, sorry about that. All right, so I got my circle there, radius R, I got the point xy, and you should realize that that point xy can be written in, trigonometric form, and it's something we've been doing since the beginning of the semester, and I'll write that down for you. So this point over here could also be written as R cosine theta plus beta, comma, whoa, it's going to get long, R sine theta plus beta. And that's something we've been doing since the beginning of the semester. All right. So I'm going to keep reading it. And then they say, and a point x prime, y prime to be written as, oh, gee, that's beta. Let me put this down over here. So I'll put this over here. And this is the angle beta. All right. And they're calling this point over here x prime, y prime. There's still an R for this thing over here. And the R's are going to be the same. It's on the same circle. We're rotating. That's all we're doing. All right. Now, what's that going to be? Well, if I look at that, that point there would be R cosine beta, comma, R sine beta. Again, I'm trying to understand what I've read over here. So the problem that comes this over here is that if you realize over here, we have an angle now. I'll put that in green for you. It's the angle of rotation over here. And I hope you start to realize is the point has been rotated theta degrees. That's it. That point has been rotated theta degrees. So let's go back and read. It says, first let the point xy be written as, well, I did that. And the other point x prime, y prime be written as, well, I did that. This may be visualized as the point x prime, y prime being rotated theta to the point xy. And what do I mean by that? This can be visualized as this point here being rotated along a circle to this point over here. All right. Then what do they say to do? And this is the part where students say, I don't know what they want me to do now. They say, and let me read that to you. A simple expansion and substitution will yield. Well, let me put that down. And I want to see if I understand what they're saying over here. And I'll write this down for you. So as I write this down, you color coded, x equals, whoops, sorry about that. X equals R times cosine theta plus beta. Now they said by a simple expansion. Well, let me expand this to see what happened by that. Now, do I know what expand cosine theta, cosine beta? I think I do. It would be cosine theta times cosine beta minus R sine theta sine beta. Right? That's some formulas. We've done those before. Now let me take a look at this over here. And when I'm looking at this, I'm looking at this, R cosine beta. Do I see that? I do. And who is that? That's really x prime. So it's x prime cosine theta minus, let's look at the next guy. And what's the next guy I'm looking at? And I'm looking at the blue guy, R sine beta. And what's R sine beta? Well, it's y prime. All right. And what am I left off with there? Sine theta. All right, let's put this over here. And this is what x is equal to. I'm going to write this in black. And this is an important thing. I'll tell you where this is later. This is important. And I'll tell you the number one reason it's important. I really want to figure out the theta that makes that bxy disappear. We'll get to there later. All right. Now what I'm going to do is I'm going to write y down now. And what's y equal to? R sine theta plus beta. They said simple expansion. Let's see what happens. R sine theta cosine beta plus R sine beta cosine theta. Well, let's do our substitutions again. And someone said, what do you mean substitutions? I'm doing these guys here still. Now, do I see R cosine beta? I do, right here. And what's that equal to? X prime. What's left over? Sine theta. Plus, let me look at this one. Do I see R sine beta? I do. And who is it? It's Y prime. Y prime what? Cosine theta. What's equal to Y? Let me write it in black for you, and then we'll go back to notes and show you where these things are. Y equals X prime sine theta plus Y prime cosine theta. I'll put a box in this. All right. Now, so I'm going to say this is really important too. Now, by the way, if you think this is difficult, the next step is going to be a killer, and that's the optional homework. But let me go back over here, and I want to tell you where this stuff is written for you. And when I say it's written for you, I'm going to actually say that you don't need to memorize this, but you need to know that we derived those two things. So what did we derive? We derived, I'm going to put this, I'm going to do it in color for you. I'll blow this up later. I know it's small for you. All right, we've derived that X equals X prime cosine theta minus Y prime sine theta. And we've also derived that Y equals X prime sine theta plus Y prime cosine theta. I'm saying we just did that. All right, what do? We just did a simple expansion and a substitution, and we yielded those two equations over there. Now here comes the tough part, and there's a footnote there for you. Let me read it for you. Footnote says it's optional homework. Now, when I say it's optional, options are what gives you nice choices in life. Are you willing to take those options of trying things? But here's what they said. Although it's challenging, you need to substitute this in to this equation over here. Then you need to expand it. And then you need to find the theta that would make the xy disappear, the term xy disappear. My claim, if you do that, you're eventually going to arrive upon a very simple formula. That the theta that would make it disappear is the solution to this equation, provided that you pick a theta, whoops, I'm making a mistake there, that you want to pick a theta that's acute. So theta is acute. What do you mean between 0 and 90? All right, so the theta should be between 0 degrees and 90 degrees. All right, that's the angle of rotation. Now we're going to go through it one step at a time. Now, when I say that, only one step at a time. All right. Now, I'm not doing the optional thing. That's in the homework for students that want to try that. What I want to do is I want to look at the method. And the method is going to have steps in it. And we'll certainly go through examples before we even see the examples in the problem sets. So I'm going to say, we have to be able to do number 1. We must do number 2. We must do number 3. Now, what's number 1 say? Make sure your problem is in this form. The only really thing I'm concerned about is I'm concerned about this. If I don't see that, I wouldn't bother with this method because I know exactly what to do. It's from the prior sections. The prior sections, none of them had BXY in it. All right. So this is only be done provided the B is not 0. If it's 0, go back to the other sections and just do that. There's no need for a rotation. After you do that, what you need to do is you need to determine what the values of the A, B, and the C. You need to do that. You need to look at your problem and say, what are A, B, and C? The next thing you need to do is solve this equation for an acute angle theta. And we'll do that one step at a time. We'll take an example. Even before we get to the example, we'll take an example. The next page. After we do that, what are we going to do? We're going to go this step over here. What does it say? Evaluate the expression that we just derived. Again, we're not asking you to memorize. We're asking you to read and follow directions. And we'll do that one step at a time. Then what you're going to do, which is nightmarish, I know it, you're going to make a substitution in this equation over here, expand it, and you'll get a new equation that will be easy. That's the claim. All right. What are we going to do then? Graph the new equation and simply rotate theta to find the graph of the original equation. And we'll talk about that with good pictures. I realize graphing is difficult. Let's start with a very simple example. All right, a very simple example. Let me write this down over here. And someone says, what are you writing down? I'm writing this down. Now someone's looking at it and say, I don't think I would have used this method to graph this problem out. And you're right, I wouldn't either. Graphing this out, it just couldn't get any easier. Right. But my intent here is that I don't want to tell you that that's what we're trying to teach you, that, you know, that all the problems can be easy, but this one's, it's really simple. If someone asked me to graph that problem out, I don't think I'd do what they're asking me to do. What would I do? I'd write down xy equals 1. Then I'll write y equals 1 over x. And this is something you did in Math 119. And what would it look like? I guess a lousy looking picture, but it looks like this over here. Now, my gut feeling about this one over here, you may not realize it. This thing's actually a hyperbola that's been rotated 45 degrees. And someone says, how do you know that looking at it? I'm looking at it. I'm seeing that hyperbola now. I'm seeing it. It's hyperbola, it's rotated 45 degrees. But anyway, I think that was easy to do. That's what you would have done in 119, and it would have been no problem at all. Now we've got issues though. What's the issue going to be? I need to go their method, all right? And someone says, why do you do that method on this one here? It's so easy. Let's go back to 119. We're trying to move you forward to more difficult problems. I'm going to get my eraser out. I know what this thing looks like already, but my goal over here is I want to go through the steps, all right? And like I said, maybe you don't need to memorize. You can go back and read, right? Let's take a look at it. So I'm wondering, is it in the form, and I'll write this down for you. Is it in the form A, whoops, I didn't mean to do that. A x squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Let's write this down. It would be 0x squared plus 1xy plus no y squareds plus no x's plus no y's, and then f is going to be plus minus 1. So I can clearly identify the A. I can clearly identify the B. I can clearly identify the C. I can clearly identify the D. I can clearly identify the Y, right? I can clearly identify the F. Now, someone says, do you need to do all that? No. What I need to identify is the A, the B, and the C. I'm going to circle those for you. And why is that? Well, again, that I should memorize. We need to plug into a formula. And let's do that. All right, what's the formula going to be? I'll write this down for you. The cotangent of twice theta is equal to A minus C over B. And that comes from the optional homework, which we not do. Let's write this down. Cotangent of 2 theta. What's A minus C? Let me write that down. It's 0 minus 0. And what's B? 1. So what do I get here? The cotangent of 2 theta is equal to 0. You might say, I don't think I could. Of course you can do that. You've done that in the past. What are we going to do? I'm going to draw the parent graph for the cotangent function. That sort of looks like this over here. Asymptotes are here, and asymptotes are here. Question is, when does it become 0? Well, I'm thinking about it, and it becomes 0 when the argument 2 theta, it's the argument over here, would be equal to pi over 2. So I'll write that down for you. 2 theta is equal to pi over 2 plus, well, what's the pattern repetition for cotangent? It's pi. Well, do you understand k is some integer? Well, let's keep doing this. You go to get theta. Oh boy, that's gonna be a tough one, isn't it? Pi over 4 plus pi over 2 k. Now, what do we want to do? We want a theta that's acute. So it's got to be the pi over 4 then. So I'll put this over here. The theta is the pi over 4. By the way, I actually prefer to use degrees. So what do I know? As I knew from the beginning, it's rotated 45 degrees. All right. How's it rotated 45 degrees? Counterclockwise. And we'll go through that later. All right. So I put out what I just did over here. I just did this bit here. All right. Now, again, if you go back to the instructions, what they tell you to do is they want you to substitute it in here. Well, I'm going to do that for you. All right, let me write that down for you. So x would equal x prime cosine 45 degrees minus y prime sine 45 degrees. And y would equal x prime sine 45 degrees plus y prime cosine 45 degrees. Well, you know what? I want to do it. I want to see what happens over here. And what do you get over here? You would get, well, cosine and sine of 45 degrees are all the same. So it's over root 2. That's 1 over root 2, by the way. X prime minus y prime. And what do you get over here? Root 2, x prime plus y prime. They had a lot of work, no doubt about it. Now what do they want me to do? They want me to substitute it into the original equation. So I need to take this over here, right? This is what x is, and this is what y is, and substitute into the equation. I'm going to see if I can do that. Let's maybe do this over here. So what do you get? X prime minus y prime over root 2. Whoa. Times y, which is get x prime plus y prime over square root of 2 minus 1 equals 0. Well, you know what? This looks really kind of complicated, but I'm going to go through it with you. And what would you get over there? X prime squared minus y prime squared over 2 equals 0. Well, let me keep going. I think I can do it. And what do you get over there? X prime squared over 2 minus, I'm sorry, I made a mistake. And the reason I made a mistake, I forgot about the number 1. And I just realized that because I put 0 there. That's a 1. I'm sorry about that. I forgot they had 1 on both sides. And the reason I said that, because I look at the equation, that's not going to go anywhere. Not where I want to go anyway. So what do you get over there? Y prime squared over 2 is equal to 1. Now, what would I do over here to graph this guy out? Well, I'm going to say it looks like a simple graph for me. And I'll put this down for you. And I want to point this is x prime, and this is y prime. This is easy to graph now. And looking at it, again, if you study the homework on the hyperboles graph, what do you get there for the vertices? Let's see about that. Not that bad, right? So it's going to be, let's see, you set the y prime to be 0, and then you get plus or minus root 2. Put this over here. Whoops, sorry about that. And this point over here is root 2, comma 0. And then I got another point over here. And again, I'm not a great artist. I realize that. Okay. All right, let's talk about the foci. All right, they're the vertices, by the way. Let me write that down for you. Let's take a look, see what we got over here. And we're going to do the the C now. What's the C going to be? I add the 2 plus 2. Let me write that down for you. So C squared is going to be A squared plus B squared. And what do you get there? C squared is 2 plus 2, which is 4. What's C? Plus or minus 2. So I think you can put that down for foci now. Put them over here. And maybe over here somewhere. So put this over here. This is the foci. And I'll write that down for you. So this foci here is going to be 2, comma 0. And there's one over here, which is minus 2, comma 0. All right. What does my hyperbola look like? I'll kind of draw it in now. Looks sort of like this over here. Not doing the best job in the world. Kind of just drawing I can't say a crappy job, but not the best job in the world. Let me write the foci down for you. I'll put that in black. What are they going to be? Well, 2, 0 and minus 2, 0. And we've done that before. How about the asymptotes? Well, the asymptotes look pretty easy too. And I'll tell you why. When x prime and y prime get really large, those two terms become equal. So what would I get over there? I would basically get, I'll write this down for you, that y prime squared over 2, again, when x prime, y prime get really large, would be really the same thing as x prime squared over 2. Well, multiply both sides by 2, and you would get y prime squared equals x prime squared, or y prime is equal to plus or minus, right? Because it's a 1 over here. I'm using square root rule, x prime. So what am I getting? Really simple lines. And what simple lines am I getting? Lines that go through the origin at 45 degrees. All right, really simple lines. They're the asymptotes. So I got my graph done, and that's really nice. I got the graph done. Like I know what the focus is in the new coordinate system. I know what the vertices are. What's the graph going to be though? Well, it's this thing rotated 45 degrees counterclockwise, and you get the picture that we talked about in the beginning. All right, so I'm going to say that's done. I want to go to the next page though, and hopefully they have a better picture for me. Let me see if they do. Let me see if I got, maybe I inserted a page there. No, they didn't provide a better picture. By the way, we'll talk about using Sage later. I want to do this problem here now. All right, again, we're just practicing at this point. We're not at examples yet. All right, so let's write this down. And, I think I probably know what I want. Is it in the form I want? I'll write this down, ax squared plus bxy plus cy squared. I want to go back in the notes and show you where this stuff is written down for you. So is it in this form over here? Right, is it in that form over there? Now someone says, what do you mean is it in that form? I'm looking at it, but what I need to identify in the form, I just really need to identify this business over here, the A, C, and the B. So let's go back to that. And my question over here is, do I know what the A is looking at that form? And I'm thankful it is. I know what the A is immediately. What's the A? Let's write this down. A is 7. What's the B? The B is minus 6 root 3. And do I know what the C is? Well, looking at it, the C is 13. All right. Once you do that, again, I'm looking at, let me point out what I'm looking at. We're looking at this over here. What am I looking for? The A, the B, and the C. And I'm seeing it. A is 7, B is minus 6 root 3, and the C is 13. Then what do? We write down the cotangent. Whoops, sorry about that. We write down the cotangent of 2 theta is equal to something. And what is it equal to? Well, it's equal to A minus C. I guarantee you're going to work out really nicely. Let me write this down. A is 7 minus C. That will be minus 13 over B. What's B? Minus 6 root 3. All right. I guarantee it's going to work out really nicely. All right. Let's see if we can do that. And again, I have to solve for the acute angle theta now. I got to get there. What's 7 minus 13? No. Let's see. That's minus 6, isn't it? And what's this give me? 1 over root 3. That wasn't so bad, right? So the cotangent of 2 theta is 1 over root 3. By the way, I'm going to write this a little differently. I'm going to say the tangent of 2 theta is root 3. So what I'm going to do now, I'm going to draw a picture. This is what we did a long time ago, solving equations, of the tangent function. I'm going to write the ratio down, root 3. Question is, where does it hit it? Well, you should know the reference triangle for that. The reference for that would be, let's write this down, 2 theta. The reference for 60, what would that be? So root 3 over 1, that'd be 60 degrees, right? Plus, I know this is frustrating, 180 degrees K, which in K is some integer. What's theta? 30 degrees plus 90 degrees K. Well, what's the first acute angle you stumble upon? Theta is 30 degrees. All right. So that's the next thing I do. So what did I do first? Is it in the form? It was. Now, really, my goal of the form is, am I seeing a B term in it, like the BXY? And if I do, I'm going for this. We need to identify the A, the B, and the C. And I did that. And then I did that equation, which we did not derive, but it's an optional homework problem. And we solved the equation for acute angle. We say it's 30. Then what do we have to do? Well, we got to take that angle theta and substitute it into our things that we're asked to do. And let me write this down for you. So it's going to be x equals x prime. And again, not as you memorize, you can go back in the notes and look at this. Cosine of 30 degrees minus y prime sine 30 degrees. We'll do that later. And then y is going to be equal to x prime. I'm sorry, did I say that right? Oh yeah, I'm sorry, I did. Sine 30 degrees plus y prime cosine 30 degrees. I guess I have to do some work over here, right? And I know it's tough. So let's take a look. And cosine of 30 degrees. That's going to be root 3 over 2, right? Minus y prime. The sine of 30 degrees is the half. Let's see, x prime. The sine of 30 degrees is a half. Plus y prime root 3 over 2. By the way, I don't like the way they're written, so I'm going to write them a little bit differently. And this might frustrate you too, but I'm going to say comma denominator 2. I realize some say, I don't want to, you don't need to do that. I'm just saying I need to do that. And what do you get there? X prime, root 3, right? Minus y prime. By the way, I want to point this out. If things are not working out, you probably did something wrong. Now, someone says, do you do things wrong? All the time, all right? So I'm going to go back over here, and I want to copy that equation. All right, I want to copy this guy. I'll pull him over here. I know this is tough. And I think I lost track of something over here. Just give me 1 second. I'll pull him around. Pull this guy here. I made him so small I can't pick him up anymore. Let me shrink it down a little bit. Sorry about that. It took me a little time to do that. Here comes the tough part. I know it's frustrating. I'm frustrated by it too. I got to plug it in. And what makes it even worse is I got an x prime now and a y prime, even harder for me to write. But let me write this down one at a time. I know it's going to be tough, and I apologize. So what's x? Well, I want to point out what x is. That's x over here, right? Put this down for you. This is x, and this is y. Well, let's write this down. So I have to square it, right? So what do you get? Root 3 x prime minus y prime. There's going to be work. There's no doubt about it. Over 2. minus, oh, it's going to be tough, 6 root 3. Well, this is going to be root 3 x prime minus y prime over 2. Oh, I got to write down y now, don't I? So x prime plus root 3 y prime over 2. Boy, I got a lot of work, don't I? Plus 13. And I got to put the y now. That's going to be x plus root 3. X prime plus root 3 y prime over 2. Just copying. Minus 16 equals 0. All right, we got to go to work. And I always say work is good to have. I think the worst thing in life is not have work. I'm going to start squaring things out for you now. So let's write this down. So 7. Yeah, it's gonna be work, isn't it? 2 squared is 4, isn't it? All right, let's go slow. That's gonna be 3 x prime squared minus 2 root 3 x prime y prime. I get it, Mary. This is going to go on forever, isn't it? Plus y prime squared. What did I just accomplish? Very little, just this guy. All right, let's do the next one. And it's going to be work. I know that. And I'll write this over here. Minus 6 root 3. That's a 4. You would get root 3 x prime squared plus, let's see, that would be 3 x prime y prime minus x prime y 2. Boy, it's going to be a lot of work. Minus root 3 y prime squared. You're going to make mistakes. All right, someone said, what'd you just do there? Very little. I did this thing. Let's do the next guy. And that's going to be plus 13. There's a 4 in the bottom. Because I squared it, 2 is 4, right? You get x prime squared plus 2 root 3 x prime y prime plus 3 y prime squared. And I'm going to add 16 to both sides because I'm kind of sick of watching that guy. So what are you going to do now? I am actually going to multiply both sides by 4. And let me write that down for you. And as I do that, I'm going to do some expansions for you. So if I multiply both sides by 4, maybe I should write that down for you. I'm multiplying this entire side by 4 and this side by 4. And I'm going to expand. So what would you get? 21 x prime squared minus 14 root 3 x prime y prime plus 7 y prime squared. Someone said, what did you just do? I multiplied this term by 4 and expanded it. That's done. Go to the next one. All right, go to the next one. Oh boy, the next one is really tough, isn't it? So what are you getting over there? Well, if I look at that, what would I get? I'll multiply by 4, so I get minus 18. Oh boy, I made a mistake there. Sorry about that. Minus 18 x prime squared minus 12 root 3 x prime y prime plus 18 y prime squared. What did I just accomplish there? This. I multiplied this term by 4 and expanded it. Let's go to the next one. All right. I know it's tough. Let's see, the 4 cancels off. What do you get? 13. I make mistakes too. I'm be honest with you. If this doesn't work out, I'll say I made a mistake. And what do you get there? 26, don't you? Wow, it's getting really tough, isn't it? And 39. And let me do the right side now. And what's 4 times 16? Let's see, 40, 64. That's not so bad. That was nice. I'm going to keep doing this, see what happens. So let's add our x prime squareds together. And what would that give you? Well, 21 minus 18 is going to be 3. And 13 and 3 is 16. That's done. Now let's do the x prime, y primes, and I'm hoping they're going to disappear. If they don't, I've done something horrible. Well, minus 14 minus 12 minus 26, root 3's, of course, plus 26 root 3's. Thankfully, they disappeared. And that's really good news for me. Let's do the next one. What do you get? Plus, well, it's going to be tougher, isn't it? 7, 18 is 25, 55, 55 and 9 is 64. These numbers are really working out quite nice, aren't they? All right, let's do what we have to do now. I'm starting to recognize it. I'm going to divide both sides by 64. So let's write this down. X prime squared over, let's see, 16 goes 4 times, right? Plus y prime squared over 1. Yep, I'm going to put the 1 there. Oh, I'm sorry, I forgot to put 64 over here. And what does this side equal? 1. What do I have? An ellipse. Let's graph it out real quick. It's going to be really easy to graph this guy out. And I'll put my x prime, y prime down. And I'm going to put down some points. I'm going to put down 4 points. And the 4 points I'm going to put down, they're really simple to put down for this problem. It's really a trivial problem. At least I believe so. If you've practiced, by the way, if you haven't practiced, nothing's simple. I'm going to say plus or minus 1. That's along the y. And along the x's, I'd have plus or minus 2. Let me write those 4 points down for you. This point over here is 2, 0. This point over here is minus 2, 0. This point over here is 0, 1. And this point over here is 0, minus 1. I'm going to draw my ellipse in. I know what it looks like, sort of. I'm going to put my foci down. I'm not exactly sure where they are, but I'll go through that with you. And, certainly I know where the center is. Center's at the origin. Let's put the foci down now. And how do I do that? 4 minus 1 is 3. So let's root 3 in. And what's this foci going to be? It's going to be root 3, comma 0. And what's this focus over here? Minus root 3, comma 0. Then someone says, did they want me to graph that? They sure did. But then what you have to do is you have to rotate this guy. And we'll look at a better picture later. Someone says rotate it. I can't remember what the angle was, such a large amount of work. You'd have to rotate that 30 degrees. Let's go back over here. Let me point out, this graph here would be rotated now 30 degrees. All right. What I want to do is I just want to go back and show you that they're getting those equations over here. Let me put this. I know it's making people dizzy, by the way. We got that. Let's go to the next page. You've got the proper graph. And I want to point out what they did. And someone says, I don't even see what they've done. Well, you want to study these things. And what they did was, I think you remember we plotted these points over here, right? This one, this one, this one, and this one. I think you remember that, or at least I hope you do. And there was an ellipse that went through that. I hope you remember that too. What did they do? They rotated 30 degrees. That's all they did. They rotated 30 degrees. So this point here would be rotated up here over by a circle. I think you get the point. Each of the points being rotated 30 degrees, all right? And again, it might look, difficult to do, but I want to point out you can do it. And we'll go to other examples. I know it's tough. The manipulations are really, really tough, all right? But it's a 30-degree rotation, all right? So I want to just simply say rotational invariance. Don't worry about it so much. Certainly if it comes up in the problem set, we would tell you, here's the deal though. And let me just go back over this with you. The method. And the method is something that you want to have in front of you as you're doing it. We did not derive this formula, but I want to point out you could do the optional homework and derive that formula. But what we're going to do when we do the problems is we're going to follow 1, 2, 3. After we do 1, 2, 3, we're going to do 4, 5, 6. All right. You can also feel free to use technology. And again, towards the end, I'll be going through the use of Sage. Thank you very much for your attention. And we'll get, certainly have the study material, of course, but we need to start doing examples to illustrate those points.